All right. And then let me see. I do not need this screen anymore. Password is while loop. All right, so let me have 2 people joining late, I think. Clean. Yeah. Kyle, did you wipe?
What was the password again?
It's a while loop. All right, any questions? If not, we're going to move on. So first, let's review warm up while loop concepts, while loop syntax. So let's start a new one. So the while loop syntax is this. Say while, and then here you're going to put a condition. The conditions can be linked by and or. And those conditions are the conditions under which the comments will be, these comments will be executed repeatedly. So this is the syntax. All right, so first of all, if you have something you want to do repetitively, then just think of under what conditions those things will be done. Or you can think of oppositely, under what conditions these commands will not be executed. So in other words, this while loop will be broken, or these commands will be stopped. Okay. So let's say, suppose I have an example. Let's say I want to do, say 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared. You know what I mean, right? So you learned that in calculus, did you? This is like an infinite series. You're trying to find the sum of this infinite series, right? And this is actually convergent. So in other words, when you add, this all succeeding numbers, then this will actually reach to a finite number, finite result. Okay, because this, 1 over 4 square, 1 over 5 square, the numbers are getting smaller and smaller. Okay, and eventually it just basically become ignorable. The numbers after, for example, 1 over 100 square is very small, and 1 over 1,000 square is even smaller. So basically, probably can ignore it. Okay, so any numbers after that will be very, very, very tiny. So basically, this thing is going to be convergent. Okay, just in case you forgot your calculus. Okay, so this is convergent series. So let's say how can we do this calculation? Of course, you cannot write the loop infinitely. Remember, computer is a finite machine. You really have to use finite instructions to do calculations. Okay, so you cannot just write a math like this, So that one, computer cannot do that. Okay, so what you have the computer do is basically what I can do. So we can declare sum, double is sum, and initialize at 0 first, right? Initialize to the 0. Make sense? And then we are going to add each numbers one by one. Add 1, and then add this 2, and add 3, and add that 1, and add the next one. So when do we stop? We will stop this addition when this number, when the item we're trying to add is so small. Make sense? Okay, so that is time we will stop. Okay, so we can just think of this, say while while, and then so it's 1 divided by something squared, so mass to the power, and then say I, right? I, comma 2. So that means I squared. If this number is bigger or equal to or bigger than some kind of numbers, then we'll do that. After that, if it's smaller than that, we'll stop. So I'll make this number is very, 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 very small, something like that, okay? So as long as the number you're trying to add is bigger than this number, then we are going to add. So what do we need to add is this. We're going to say sum, result sum equals to sum plus 1 over mass to the power, and then I, comma 2. So if this number is bigger than that, we'll add it. If this number is smaller than that, we forget it, and the loop will be broken. So now we realize that we have to have I, right? So we declare integer I first. Integer I. Let's start with 1 first, right? Start with first one, and then second one, and third one, so 3, right? And after we do the loop, after we finish adding that, so now I has to increase by 1, so I plus, right? So basically in this case, you have some kind of combination of while loop and a for loop, because we also use index here. So I plus, like that, right? So after add this I, then we just increase I by 1, and then do it again, check that. So if the I is, so 1 over the I squared is bigger than that, then we do it again. Okay, if not, then this loop will be broken. So then the command will come to here. So the control focus will come to this place. So the loop will be finished. All right, so this is kind of like a warm-up of your while loop. Okay, so for now, let's open up your Visual Studio. Let me also open up your node, which is week 7 node. I think we did example 1, 2, 3, and now let's do. So we were doing 5. Okay, so this is the place I was talking. We stopped. So basically, what does this do is you keep on divide x by 2 until the x is no longer bigger than 2. So basically, this result and the result will be the last binary bit. The last binary bit. Let me just repeat what we did, how we do binaries, right? So suppose I have x equals to, so if x equals 23, right? So to find the binaries, first of all, you're going to use 23 divided by 2. So the quotient is going to be 12, and then this is going to be, quotient is going to be 11, and then this is going to be 22, and then this remainder is going to be 1, and this 1 will be the first binary bit, right? And then you're going to use 11. So now you just think of that, think of this process. This one is going to be just x equals x divided by 2, okay? So x equals x divided by 2. And then you're going to use x divided by 2 again, so 11 divided by 2 again. So this time you get a 5, and then 10, and the remainder is 1. And that 1 will become your second bit, second binary bit. Okay, and then this is going to be again x equals to x divided by 2 again. See that? From that, you get a remainder. And then use the remainder to make the second bit. And now you do it again, so 5 divided by 2. So the quotient is 2, and then this is a 1, this is 4, then this is the 1 again. So that will be your third bit. So if you continue that, so that will be a third bit. Okay, so again, what is this? This is x of x divided by 2 again. So this process is x divided by 2. And then finally, you have 2. So 2 divided by 2, quotient is 1, and the remainder is 0. So that 0 will become your fourth bit. So if you try and add that to here, it will be this one. Okay. And then finally, you have 1. So this is, again, this is x divided by 2 again. X equals to x divided by 2. Right? And then divided by 2, and then you get 1. So then finally, your x divided by what? 1 divided by 2. So of course, the quotient is going to be 0, and then the remainder is going to be 1. The remainder, this last one, which is the same as this one, and that will be your last bit, highest bit. So if you're trying to add that to the binary number here, that will be here. So this one will be here. So essentially, what we finished last class was this. So after you finish this while loop, then this end result x is going to be something like this. It's the highest bit. It's either 0 or 1 will be highest bit. Okay. So now I'm going to extend this a little bit to really perform this process. Say suppose I need to binary conversions. Okay, so I give you an integer, and then I want you to find what is the binary numbers. So not just highest bit, but I want you to get all the bits, including this, the other bits, lower bits. Okay, so let's open up Visual Studio and trying to perform that process. Okay, so there's many years ago, probably 20 years ago, I was teaching in another university, and one of the students came to me, told me that she was interviewed for one of the questions to say how do you convert integers into binary numbers. I was surprised because for MIS we typically don't require students to know that. That's only for like a computer science majors. But anyway, since then I do cover some of this basic stuff, including algorithms, data structures, and also there's a binary numbers. So let me let's say we did I think it was a fifth example, right? So we'll just use the fifth example. Continue use the same example instead of using a new one. Okay, so this, yeah, right there. So we basically did something like a binary, whatever. Let's say what do we have? Button, binary here. So let's say what I'm going to do here. Okay, so I'm going to create 2 text boxes, and then the first one will show just regular number, and the second box will show binaries. And then when I press this button, okay, so I'm going to add 2 more text boxes. Tools. Hold on. Tools. Text box. So I'm going to use this one for just regular decimal numbers. Let's change the name to txt decimal, okay, DEC. So this one will get like any integers in here. Okay, integers that 10-based. Okay, it's called decimal numbers. And then we're going to have a text box to show binaries. Okay, so for that one, I will make it a little bit longer. And let's just call that a txt binary bin. Okay. All right. So again, you just put any integer in here and press this button. The result will be displayed in this second text box, which is binaries. Okay. All right. Does everybody follow me? Anna, are you okay?
Yeah, I was wondering what the password was. I got here a little late.
Okay, the password is a while loop. While loop is one word.
All right, thank you.
So we're using the same project as we did on Monday. So what I did is just create two text boxes, one for integer, one for binary numbers. All right. Okay, let's move on. So let's go to buttons, binary buttons, okay? So here we declare integers, but that integer is not going to be this fixed integer. Instead, it's going to be from the first text box, which is txt tag dot text. Okay, so of course you need to do conversion. Convert to integer. So integer 32 is the default, okay? All right, so now we get the integer. And the integer is in x. So now we just need to keep on dividing by x, okay? So first of all, we need to declare a result. So result is going to be like a text, okay? I'm going to make that text because otherwise you have to declare special binary numbers. So I will say result. So start with empty, so nothing in there. So result is empty first. Okay. All right, so now what do we do? So first, when this x is bigger than equal to 2, we are going to divide by 2, and then we are going to get the remainder. So I'm going to declare a variable just called remainder. Okay, before the loop. Okay. So this is also something like a tip, programming tip. If you need a variable to be declared, just try to declare before the loop. Don't declare variables inside the loop. So what does it mean is if you declare the variable inside the loop, that means every step is going to create a new variable, right? So that's just a waste of memory spaces. Okay, so we declare that. And now when the x is greater than 2, what do we need to do? First of all, we need to get a remainder. So we'll say remainder is equal to x and the percentage sign and a 2. So divide by 2 and take the remainder, right? And then we're going to add that to the result. So what do we do is a result equals to, so remember we are adding the new result to the left. So we are actually going to put a remainder first plus existing result. So whatever I found, I will put on the right. And then what I need with the new one, the new remainder will be added to the left. Do you remember what I did? So we first make that create the first division, and then remainder will be the last bit. And then we do the second division. The second bit will be added to the left of that. So that's what we do here. So we add the remainder to the left of existing result. Okay. And then you do, so that get a division, right? You get a remainder, and then of course the new quotient is going to be just one divided by 2. So this you get a new quotient. So let me try the comment here. It's new quotient. Okay. And here, just get the remainder. Find remainder of x divided by 2. Right? And then here, let's just add a comment here. Add remainder to the left of existing result, existing bits. Okay. So again, this is the while loop, and then we just extend that to finding all the bits, and also every time we find the remainder, add the remainder to the result, and then this final result will be the one we need. So so what do we need to do? So after that, okay, so x, after you do the division, this x will be equal to 0 or 1. X will be equal to 0 or 1. So basically, you do not need division again. So I'm going to use if. So if x is equal to 1, okay, then if you're trying to divide, if you do division again, then you're going to be, remember, it's going to be 1 again. So you basically just say a result equals to 1. Okay, just simply it's just 1 plus result. Okay, so you added 1 to that, and else that means if x is 0, then result is just equal to result. You don't need to add 0 to the left, right? Because the result equal to result. Something wrong here? So basically you do nothing here. So in other words, this else you really don't need it. You don't need that, okay? So if result equal to result assignment made to the same variable did not mean assignment new something else. So what is this one? Basically saying that we are assigning. This basically just no change. So basically it's fine. This is just a warning telling you that you're trying to put a variable. There's nothing changed. Okay. So basically this statement is not really needed. Okay. So basically after x is greater than 2x, if this while loop is finished, x will be equal to 0 or 1. So if it's 1, then you add 1 to the final result. Otherwise you just do nothing. Okay. All right. So now let's use the final binary text box to show the result. Text box equals to result. Okay. There we go. So now we have a complete binary conversion calculator. All right. Is everyone okay? Are you okay, everyone? So you can test it. So let's say previously we used use hand to do calculations, and it was kind of pretty tedious. But now, whatever integers, this can be done very quickly, right? So that is the power of programming. Okay. Are you okay, everyone? Good. Now, if it's okay, now let me go to look for next example. Let me see that. So we did that, and we did the binary conversions, okay? And then here, let's do another one. Let's say another while loop. So example 6. So this time we can use the same text boxes, but let me tell you what I want to do, okay? In ASCII code, ASCII and also Unicode, both, okay, they use binary numbers to represent alphabetical letters, like A, B, C, Ds. Unicode actually can use binary numbers to represent any characters in the world, including Chinese, Russian, even though those characters we cannot recognize, but they can all be represented by binary numbers. And essentially, those binary numbers, of course, will be corresponding to like integers, right? So what I want to do in this case, in this example, is that if I give you an integer, any integer, I want you to find out what is the character for that. So in other words, we are trying to create some kind of like ASCII table ourselves. An ASCII table using from 0 to 127 That's two integers between 0 to 127 for any characters. So in total, you have like 128 characters, okay? Including space, comma, semicolon, anything, and some non-printable characters also. So all the characters are represented by integers. So what if you have integer is more than that range, more than 128, more than 127, or less than 0? So in that case, you will have to make them to fall into the range, fall into that range between 0 to 127. For example, if you have a number bigger than 127, you just keep on subtracting 128 from the number until the number is falling between 0 to 127. If you have a number, integer number is smaller than 0, then you just keep on adding 128 until the number fall into the range. Okay? And after the number is falling to the range, then you can just use the number to find the corresponding character using this simple statement. So like basically just casting. You cast the integer into like a character. Does it make sense? So we are going to use a while loop to perform that. So I'm going to create a new button, but we'll use same box, same text box. Put it here. Now let's see if I do another button. And then let's just call that ASCII code. Okay. So let's say the text is ASCII code. ASCII stands for American Standard Code for Information Interchange. ASCII. Okay, so let's just change the name of the button is BTN code. All right. So let's double click on this button. And the first thing we want to do is always have the declare variable to hold the input data, which is integer. Let's say integer x equals to txt decimal number dot text. Okay, so you need to do conversion. Convert to integer 32. Okay. So you always declare variable to hold the input from the text box or from any like controls. And so that's the first step. And then the next step. So in this case, we want this x may not be in the range, may not be between 0 to 127, right? So we are going to process it. So in case if this number is more than 128, so while x is greater than 127, then we will just keep on subtract x equals to x minus 128. So we subtract 128 from 120 from the x, from this integer. Okay. So this will stop, right? This will stop. This will stop to the point that x is going to be less than 127. Okay. But also we need to handle opposite case. What if x is less than 0? So while x is less than 0, then we have to add 128. So then we x equals to x plus 128. So until that number is bigger than 0. So then after these two while loops, you will be able to make sure that x is going to be between 0 to 127. And at this point, now you can cast the integer into char. So let's declare char first. C equals to the integer, just x. Okay. However, the type does not match. Right hand side is the integer, but left hand side is a char. So we have to use explicit cast. So just cast that integer into char. Okay. And now let's try and put this character into the text box. So txt, which is, let's just use a binary, the text box name again. So it's really it's not a bad binary. So txt, the text box equals 2. So we are going to make C, okay, represent equal to C, but then we need to convert C into characters. So this one, you can do say C dot to string, okay, to string. Okay, so there are a lot of things you can just, instead of convert to string, you can also just use the number, the variable to string, that will change it to string. So that is same as like convert to string, okay? That's it, there we go. So that basically, that is the essence of the code, is just use a while loop to subtract 128 or add 128 until the number is between 0 to 127. Make sense, everyone? Okay, now you can run it. You can run. So let's say I want to put any bigger numbers here. So I don't know what number is that. So basically, I want to convert that integer into character. So what is that? I don't know what is this. It's special, very special character. Okay, so let's try and add something else here. Crashed. The integer is too big, I guess. Value was either too large. So integer, remember, it can only be like a 2 billion, unless you want to do like a long integers. So let's try and put a smaller number here. Okay. So that's capital G. Add 1 here. Still capital G. That's interesting. H. All right. Okay. Any questions? No questions? We did example 7 on board. So let's skip that one. Okay, this one, number 8, is a little bit more involved. Let's just do that last, okay? So let's do example 7 after I finish all the examples. Okay, so now let's do switch for decisions. So remember, so far we learned how to use if, else if to make a decision. So that is basically just like a contingent execution of commands. So make sure you understand the difference between while and if. Even though inside the parentheses you both use conditions, but if will only execute the condition, execute the statement once if the condition is met. But while we just keep on repeating it until that condition becomes not met. Okay, but the switch statement is kind of special case of if statement. It's a special case. So that means you don't have to use switch, but switch help you to simplify the code writing a little bit. So what is this is syntax? Okay, I'm going to show the syntax. I'm not going to write that syntax again. So basically, use a switch, okay, and the inside the switch is basically some kind of expressions. Expressions just like variable, or using variable for additions, subtractions, all that. Okay, so the expressions, then the expression is going to get a value, right? So those values will be used to determine when do you run statements. For example, if the value is this one, is the first case, then you run statements. You run these statements. If value is the second value, because the expression has second value, you do different kind of statements, and so on and so forth. Okay, the final case is say what if value is not in those cases, then you do default case. So this is like just an optional one. So you can default and you do that. So let me use the example to illustrate that. Suppose I have weak numbers, okay? week numbers. So we go 0, 1, 2, 3, all the way to 6, right? So I want to change 0 to Sunday, 1 to Monday, and 2 to Tuesday, like that. Okay? So in that case, you can use if else. However, it would be much easier to use like a switch statement. Okay, so what I'm going to do, let's just use the same project to create that the weekday mapper. So you can do the same thing with the month name, right? Month number and month name. You can also do something similar. So I'm going to have like a number here, 1, 0 to 7, and then I want this one to show the second text box to show the name of the week. Okay, and the name of the weekday. So create a new button. So let's just change the name to weekday. Okay, weekday. And then give a name for the button. Say BTN weekday. All right. So remember, in this case, we are given an integer here. Integer. Well, you know what? We can just do opposite. We can have name to convert into name converted into numbers. Either way. Okay. So let's just do that way. So basically, we give a name and then we convert to number next. Okay. Make sense? Okay. So in this case, we are going to get input from left-hand side, which is like a name, like a weekday name. So that will be some kind of string, x equals to txt. Let's use decimal value box dot text. Okay. So we have that value, the name inside this text box, right? Inside this. Okay. And then just in case somebody may type mixed cases, somebody may type small letters, somebody may type uppercases, right? To be uniform, let's try to make all of them to uppercase or lowercase, does not matter, okay? So we'll say to uppercase. Okay. So that way we do not have to handle special kind of input, okay? Now, so basically now we just basically writing many if-else statements. So if this x equals to Sunday, then you say result equals to some kind of a 0, right? So I'm going to put integer say result, okay? Okay, integer result. And then instead of if-else, I'm going to use switch, and switch based on the value of x. Okay. So this is curly brackets. And now you list all the cases inside. So first case. So if case is Sunday, remember now you have to use all capital, case Sunday. And then after each case, then colon. Then you go to the next line. You type what is going to be result. So result, in this case, equal to 0. Okay. And then after that, you have to say break. That means this will only be executed once. So when this case is finished, then this entire switch statement will be finished. You do not have to do it again. Okay, you do not have to look at the next case or next case. Does it make sense? So that's what the break means. Yeah. So this is one case. Now let's do the other case. Case Monday. Okay. Then you say result equals to 1, and then break. Okay, so now you should be able to finish the other cases. So I'm going to type quickly without explaining. Break again. Wednesday break. Last one is Saturday. And then break. And we can also have a default. So basically, if for any others, let's just try and make a result equals to say -1. Okay, so then we know what is happening. So then break. All right. So if any text is not Saturday or Monday, what those kind of weekday names, then we just say result equals to -1. Okay. So after this switch, now we should have a result, and now we can just put a result into the text box. So txt binary text equals to result. Okay. And then of course you need to convert. So here, let me show you again. So you can say to string again. To string. So that's it. That's the same thing as like convert to string. Okay. Put a result inside the parentheses and convert to string. All right. So this will convert names into numbers. Okay, you can test it. Should be working without any trouble. So basically, this is a very simple switch statement. Here the expression just involves the value of x only. So that may not be always the case. So you can use x and y, kind of doing calculations, and then based on the result of the calculation, so you decide the cases. Okay, so the value is, if you equal to some kind of value, then you do this statement. If you have some other values, you do different kind of statement. So basically, you can write a nested if else, if. Keep on doing that. So that will basically receive the same result. So switch statement can be replaced by if else, but not other way around. Okay, just like a for loop and a while loop. While loop can replace for loop, but not other way around. Okay, the switch statement can if else can replace switch statement, but not other way around. Okay. I think I missed something here. There's a colon here. Okay. All right, so we can test it. So let's say, suppose I put Monday here. So it does not matter which case now, because we all convert to capital case. So that's 1, right? So it was a Sunday. Okay, and should be 0. And now if I do something else, which is not of these names, and then should get -1. Okay. All right. Next. So this explains case. This chart explains how a switch statement is executed. So it's like a contingent execution of certain statements depending on the case value. Okay. So if case value is something, then you run this code. If a case number second is different kind of value, then you do different kind of statements. Okay. So it's just like if else. So what I'm going to do next is actually a little bit more interesting one. So suppose I have some kind of like letters or like text. So that some companies instead of using phone numbers, they use like use a text. For example, let's say call ATT, right? So this kind of text. So let's say I want to convert the text into like phone numbers. Okay. Does it make sense? What is that called? They use phone, like instead of like phone numbers, they use text. So for example, your ABC corresponding to number 2, I believe, right? ABC is number 2, and then G, what is it? Let me see the case. ABC is 2, and the DEF is 3, something like that. So we are going to put like a text here, and then I will press this button, and then we'll get like actual phone numbers. Okay. All right. So you understand what I mean, right? Okay. So now let's say how can we do this? So how can we do this do this? And so if I give you a text, then of course I can convert the text into individual letters. So the text consists of individual characters, and then for each character, then we're going to use a decision. So if the character is A, B, or C, then I will change that to 2, number 2. Okay, does that make sense? Otherwise, it's D or E or F. So now remember here. So if you have several cases corresponding to the same statement, this is how you write it. So basically, previously we say for each value, for each case, you can have separate statements, right? But you can also have several different cases run same statement like this. Okay, so you say case A, case B, or case C, then you do that. Okay, so now let's try to do that. So what we need to do is I'm going to create a new button first. Not this one. So I'm going to create a new button, but it's still using the same 2 text boxes. Okay. Then I just say for this one is phone text. The label is text. Label is form, and the button is BTN phone. Okay. So remember, we are going to get text from the left box, and then put a phone number on the right. Okay. So the conversion is based on the phone pad. Phone pad. If you have a phone with you, and basically use the same character mapping. Okay. Double click on that. So first of all, we declare a variable to hold to receive result. So let's say this is also x equals to txt decimal number. That's the left one, and our text. Okay. That's the first thing we want to do. Second, we need split that text into array of characters. So we need to split the text into individual characters. So to do that, we are going to declare array. So let's say chars, okay, equals to x dot to char array. So that basically is a simple built-in function that will split text into individual characters. So-called a string just simply a stream of characters, right? So you can just convert a string into characters like that. Okay. Now we need process these characters one by one. So we have many characters, so we're going to use a loop, right? So in this case, of course, we can use for loop because we know how many characters is inside the chars. That's just simply chars.length, right? Chars.length. So you will be able to find how many characters. And then for each character, then we just process it. If character is A or B or C, we change the number to something, okay? So let's do while. Let's write a while loop first, okay? So we try to always do that, like just starting from scratch and also brainstorming how we write the code. Okay, so instead of just telling you, logically, what is very streamlined way of writing code, I would just do the same way like what you would typically do when you write a new code. Okay, so we'll say, oh, we are using while for loop. We can use for loop. So we don't have to use while loop in this case. So for loop, so for integer I equal to 0, okay, that's the first letter, and I less than this chars dot length. that is the stopping condition. So it basically tells you that how many characters in the text, right? And then I plus plus. Okay. Now we need to convert each character, map each character to a number, the number corresponding to the number on your phone pad, phone dialing pad. Okay. So I'm going to declare a variable, integer variable, to hold that number. So let's just say this is number. Okay. Number. So we are going to use a switch statement this time. So switch based on the character. Okay. Switch based on the character, which is char I. Okay. Curly brackets. So now let's say if the case is letter A. Oh, by the way, we still all have to do conversion also. So make sure it's uppercase, okay? Because otherwise you get mixed case. So what we do is we will convert the text into uppercase to begin with, to upper. You understand what I mean? Because otherwise this character may be like small letter A, small letter B, right? So we change it to capital letters. Or we can change it to lowercase, either, does not matter. So this is case A or case B or case C. So in all the three cases, the number will be equal to 2, right? And then break. So this is colon, not a semicolon. Okay, so now we handle the next three cases. What are three cases? A, B, C, D is D, F, right? D. Case E. And case F. Okay. So then in that case, the number will be equal to, oh, sorry. I use a single quote, please. I did not notice that. Single quote for characters, not double quote. Double quote is for text. So, because case, the child is a character. All right. Then this number equals to 3. And then break. Okay. And let's do one more time. So case DEF is a GHI. Okay, number equals to 4. Oh, actually we have 2 more cases, break. So we have a GHI, so 2 more cases. I'm going to just, you can just copy and paste, GHI. Good. All right, so this process will continue. I'm going to stop. So I'm going to say default case, default. If default, then number equals to 5, and then break. All right, so this will go through every character in the text, and then convert the text into corresponding numbers. Okay, but finally we need to somehow keep track of all those numbers, right? So I'm going to put that into, let's just use text. Okay, use text. So string as a result. So let's start with 0. Start with empty string first. There's nothing in there first. Okay, result equals to nothing. Okay. And then after we have the first one, then we are going to put that number into the result. So I'm going to say result equals to, so which way we should do? So 0 corresponding to the left character, 1 second to the left, so on and so forth. So for anything that after we have a 0, then we add 1 to the right. So actually in this case we should write left plus whatever number that we get. Okay. Does it make sense? So basically we are adding, in this case we're adding new numbers to the right of the existing ones, right? It's starting from 0, so 0 corresponding to the left character, the leftmost character. Okay, and then second character will be added to the left of the existing one. All right, finally, we can report the results. So let's use a binary text also to report the text, which is result. Okay. And there we go. So we have a phone conversion. So in this case, expression is also pretty simple. Just look at each character, I, inside the text. If the character is A, B, C, then you do this. A, B, D, E, F, you do this. Okay. And let's just illustrate the case switch statement. It's just so if you're trying to think of this as like if else, I guess you have to do something like this. If this char equals to A, or char equals to B, or char equals to C, then this is the result. Else if char equals to D, or if char equals to, if the char is whatever, char I equals to E, or char I equals to F, so you put O, you have two pipelines to connect the three conditions. Okay. All right, you can test it. It should be working without any trouble. So let's just try and put something simple, say call ATT, okay? And then let's say, what is the phone number for that? 225-5255, okay? All right, we have last 15 minutes, and we'll use that 15 minutes to conquer a very difficult problem. That is to do factorization. You know how to do factorization, do you? You forgot? You learned that in which way? Second grade or third grade? Fourth grade, I believe, right? Third grade, probably third grade. After you learn the division, you should be able to do factorization. So, for example, if I give you like a number like a 12, right? So how do you do factorization? You're going to divide by 2 first, right? So divide by 2, so 2 is going to be factor, so that will be equals to 2 times 6, right? And then you're going to continue the 6 divided by 2 again, so there's 2 times 2, and then times 3. So then the prime factors will be just 2, 2, 3. Make sense? So let's do it again. Suppose you have a number like a 15. So you're going to divide by 2, there's nothing can be divided. So you're going to divide by 3 next, right? So you're going to say 3. And after you divide by 3, then the remaining, you're going to 5 here, okay? Then you divide the 3, you're going to divide by 3 again, cannot be divided, and then you divide by 5, and just divide by 5. So basically, this is the prime, two prime factors. Make sense? Want to do one more? 50, okay? So this time you're going to take 2 out first, and then 25. And then you divide by 3. You divided 25 by 3, but you cannot divide, right? Cannot wholly divide, so you're going to divide by 5. So then you're going to get 5, and then times 5. That's a prime factor. So I'm going to find a way to do for any integers, trying to find the prime factors. Make sense? Okay. So first of all, the idea first, okay, and then we put in the code. I believe that's the only example we have. Okay. So here we get forget about this. Okay, so you use a variable to get the integer first, right? So that's the same thing we did before. So always get the result from the form. And then we are going to divide by 2. So every time if I can divide by 2 wholly, then the 2 is going to be a factor. So we add that into the list. Okay, and then divide by 2 again. And then divide by 2 again to see whether that can be still divided. So if it is, then that 2 is going to be another prime factor. So just keep on adding 2. So this the first while loop. We are just trying to get rid of all 2's, all factor 2's inside the integer. And then for the rest, we will start from 3. So you're going to do 3, right? And then you don't need to do 4 because 4 is already out. There's the number after you keep on dividing by 2, there will be no more 2's inside, right? So then you can just do like a 3, and then every time you increase by 2 because you can just consider all even numbers or all odd numbers, sorry, divided by 3 or 5 and 7 like that, okay? Continuously. So every time we pick up a number like a 3 or 5, we will keep on dividing it, keep on dividing by I. If it's divisible by I, then the I is a factor. So add to that. Okay. So this process is just like use a while loop and also for loop and also while loop combined together. So that's why I said this is a little bit more complex and more complex. Okay. So let's do that in code. Hopefully we have time to finish. So let's try to do, you know what? I am going to create another button. Just to put button here or here. Here. Okay. Okay. And then I am going to change the name and the text. So this is factorize. And the button, factorize. Okay. So I'm going to use the same text box to get initial integer values, integer numbers. When I press this button, I get integer from here. And then after the result is obtained, I will put that into this list box. Put all factors into this list box. Okay? Are you with me? Okay, so let's do it. So first, declare a variable to hold the result. Let's say integer n equals to txt decimal.text. Okay. So you need to do conversion. So let's say this time you need to convert to integer 32. Okay. All right. And next, I'm going to create a list to hold all the prime factors. So list of integers. Let's just say this is prime factors. Okay. Equals to new list. So use constructor to create empty list. So now after we find the 2 is factor, we add 2 to the list. If we find 3 is a factor, then we put 3 into the list. Okay. So first, let's just try to handle 2's. Okay. So if x divided by 2 percentage sign equals to 0, that means 2 is a factor, right? 2, no, this is not right. It's actually n percentage 2 equals to 0. Okay, so use a while loop. Okay. So we will divide by, so first we take the divide by 2 and take the remainder. If remainder is 0, that means 2 is a factor. So now we can add 2 to the factor, to the prime factors. The prime factors that add 2. Okay. So divide by 2, take the remainder. And of course, the result, the n is not good. The n is going to be 2 is already out, so you're going to take 2 out. So n equals 2 divided by 2. And then you go back to the while loop again to see whether it still can be divided by 2. If it is, then add another 2 to this list. So you just keep on adding more 2s until there's no more 2s, no more even numbers inside the number. Does that make sense? Okay. Now we need to handle, after all the 2s are out, after all the 2s are factored out, then we handle 3 or 4, 3 and 5 and 7 like that. So we are going to use for loop first. Okay, for integer I equal to 3. Okay, and then I should be less than whatever n so far, right? And then I equals to I plus 2. You understand this time we incremented I by 2 because we do not need to consider 4, 6. We only consider 3 and then 5 and then 7, only the even numbers, right? Okay. So every time we pick up I equals to 3, then we do the same thing, divide by 3, and then until there's no more 3s, and then we move on to 5. Okay, so let's do while loop inside. While n percentage sign I is equal to 0. Then we add I to the prime factor. So prime factor that add I. So you divide by I. This just get the remainder. Just say that if n can be wholly divided by I, then you add the I. But then of course you have to actually do it. So n divided by I. Okay, and then you go back to while loop again to say whether it can be still divided by I, still divisible by I. If it's still divisible by I, then add another I. So on and so forth. This while loop will continue until there's no more i's. So just imagine I equals 3, this is finished. I equals 5, this is finished. Okay. All right. So that will be able to handle all other cases. So finally, we just need to show the prime factors into the list box. So list box was named is data. That data source equals to the name of the list, which is the prime factors. Okay. Okay, so this loop, this time we use a so-called nested loop inside the loop. Okay, so yes, it's more complex than any other examples. I hope you have. Do you have any questions? Does anybody have questions? No, you can test it. You say put any type of integer, big integer, as long as it can be handled by integer variables. Okay, so I'm not sure that is any number that can be factorized. Oh, it does. Okay, so 7, 41, 73. Perfect. Okay. All right. Anybody has questions? Last minute questions? Take a look at your homework. I think I already did that last class. Everything you need to do for homework was already covered by the previous class. Okay, so today we just more examples to do to show while loops. especially the last one, which is more complicated. And the binary conversion one is not that easy. It's not that easy also. So just trying to take a little bit of time to appreciate, understand this. If there's no more questions, have a good weekend, everyone. I'll see you next Monday. If you have questions, just stay around for a little bit.